All right, hello grade 10s. This will be the last lesson of the week, the third similar triangle lesson. And if I look at what I've done in the past here, we'll be about halfway through. So it's a short unit. So we'll have rest lessons next week and then review and a test the week after that. And it will then be June, believe it or not. Okay, I have here your first 5-minute question. These triangles are similar, and they're similar the way that they look that they're similar. It sort of goes in this order. 1, 2, 3 is similar to 1, 2, 3. So you don't have to think too much about it or rearrange anything. I just wanted to give you an easy question. I would like you to determine the lengths of x and y. So please go ahead and pause it and try it. Okay, so step 1 is to do the ratios. So 22 over y equals x over 72. Now so far we don't have a complete ratio. So at this point we can't solve anything. Equals 35 over 65. There we go. We've got our key, our complete ratio. And please remember the order does matter. You always do one triangle on the top and the other triangle on the bottom, and make sure you go in the same order around the triangle. So let's do side x first. For side x, we need the ratio with x in it, and we need the complete ratio. X is being divided by 72, so we multiply by 72 on the top and the bottom. These cancel, remember that was the goal. And we get 35 times 72 equals, divided by 65, 38.8. So approximately 38.8. And then we look at the triangle, and yeah, that's longer than this side, so it makes sense. For side y, or sidey, we have 22 over y, so we need the ratio with y in it, equals 35 over 65. Now in this case the y is on the bottom, so the first thing we do is we flip it upside down. And I'm really hoping that you did pause and try this. And now we multiply by 22 on the top on both sides. These 22's cancel, and we get 65 times 22 equals, and then divide by 35, and I get 40.86, approximately 40.9. And if we look at the triangle, yeah, y is the shortest side, and it's shorter than both of these. Okay? Today will not be a hard day, I don't think. There's not a lot of difficult days in this unit. There might be a difficult problem or two, but overall it's pretty simple stuff. All right, there are four ways, that we can declare triangles to be similar. The first one is called AAA, or just AA. So if any two triangles have two angles the same, the third angle must be the same, and the triangles are similar. So we did this yesterday, remember? We said that if all three angles are the same, that's what it means to be similar. One is just an enlargement or a shrinking of the other one. But what I can say now is that even if two angles are the same, we know they're similar. The reason is, if we have two angles in both that are the same, because the angles add up to 180 in both triangles, the third angle will have to be the same as well. The next one is side, side, side. So if all three sides of two triangles are proportional, the triangles are similar. So they don't have to be the same, right? If all three sides in one are double the three sides in another, then we know they're similar. One is just double the size. So now we have angle, side, angle. So angle, side, angle is going to look like this. So let's say we have this triangle here. Okay, so let's say we know a side, this side here, and we know these two angles. Okay, and then we have another one that's bigger, but these angles are still the same. So this angle and this angle are the same, and this angle and this angle are the same. Well, that's two angles being the same, right? And if you think about this, if you were to continue drawing these lines, there's only one place they can meet. So basically, again, this is just the same as saying two angles. Okay, so that sort of follows from this one. The third one's a little bit trickier. So if we've got side, angle side, let's say this is x, and then if we enlarge it, and the angle is the same, and the sides are proportional, so this is like 1.5 times larger, again, if you were to draw that third side, you only have one option. So if we have a side angle side relationship, we know the triangles are similar. Okay, and again, these sides don't have to be equal, but they have to be proportional. So this side has to be the same ratio to this side as this one is to this one. Don't worry too much about this. You'll see what I mean when we do examples. Okay, so let me just check on our handout to make sure I'm doing things in the right order here. All right. Yes, all right. So we're asked to name a pair of triangles that are similar. So the first thing I want you to notice is this. Angle B is the same as angle C. So angle B equals angle C. And then you'll notice this. We have an angle here and an angle here. Now you might remember from grade 9 that these angles form the X pattern. So we can say that angle F equals, oh, they're both called F, so they're definitely going to be the same. And we would say by X pattern. And that might be familiar from grade 9. It's not a big deal now, but that is how I would like you to explain it. And then we could say angle A equals angle E by, and you would call this the interior angle theorem, or you could say because all three angles add to 180. So if these two angles are the same, and these two are the same, the third one in each is kind of locked in, right? Okay, so we haven't answered the question yet, and that question is, what two triangles are similar? So check this out. Because of the way we've done this, our first triangle, we're going to read like this, BFA. So triangle BFA is similar to triangle CFE. Because all these pairs of angles are the same. And if the pairs of angles are the same, the triangles have to be similar. Okay, now we're asked to find the missing length of CE. So that's going to be right here. I'm going to call it little f. Okay, but I'm going to call it little f2. And you'll see why in a minute. So let's write our side similarity statement. So B over C equals little f over little f. Well, that's weird, right? So what we're going to do, we're going to call this triangle 1 and this triangle 2 because they both have a side f. So BAF is the top one, so that's going to be F1 and this is going to be F2. Equals A over E. So BFA, BFA, CFE, CFE. Now we plug in just like yesterday. So little b is across from big B, it's 3.8. Little c is across from big C, and it's 2.9. So there we go. We have our complete ratio. F1 is F up here, so this is F1, and that's going to be 3.1 over F2, which is, we don't know, equals A over E. So A is, oh, we don't know. And E is, oh, we don't know again. So let me tell you right away, if you ever have a ratio where you don't know either thing, you cannot do anything with that. So just ignore it. So now we're going to use the two ratios that we have to solve for F2, which is the same as side CE, because it goes from C to E. Okay, so first of all, I got to flip everything upside down because my variable is on the bottom. So F2 over 3.1. You could have called it X. It doesn't really matter. Now we multiply by 3.1, just like yesterday. So again, there's not much new today. And F2 equals, so 3.1 times 2.9 equals, divided by 3.8, 2.4, approximately 2.4. Now let's look at our diagram and see if that makes sense. It'll be centimeters. This is 2.9. This is a bit shorter. 2.4 makes sense. Okay, moving right along. Are these two triangles similar? Well, let's see here. We know that these two angles are the same. We don't know this angle. 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 So here's a cool thing. To do this, we will check the ratios of the corresponding sides. So to do this, we're going to use a calculator. So we first check these. We do 9 divided by 12. So 9 divided by 12 is 0.75. Now, if the other two sides are in the same ratio, if they divide to be the same, which they do, that tells us that we have a side and a side that are proportional and an angle that's the same. So we have SAS. We got some SAS. And if you go back to here, that's one of our rules. Side angle side. So yes, they are. SAS. Okay, now let's get into some real life applications of this. It's a beautiful sunny day here today. I'm recording this on May 20th, which I think is Wednesday. And if we were at school today, we would have gone outside and we would have used the bright sunny day to look at our shadows, and we would have done some math, and it would have been fun. I mean, it would have been fun as far as math is fun, but I think it would have been good. So let me explain the way this works. Let's draw a diagram here. So James is 1.5 meters tall. Okay, so James, 1.5 meters tall. His younger brother is 0.75, so half of his height. This is little brother. Okay, so there's the two people. We'll put them over here. All right. So if James's shadow, okay, so let's draw his shadow. So here's his shadow. So if James's shadow is 2 meters long, we want to know how long is his little brother's shadow. We'll call that x, because we love to use x. All right, now think about this. The sun is super far away. How far away is the sun? All right, how far away is the sun? 151 million kilometers. That's super far. Now, if you have a lamp, I think it would be kind of neat if you took that lamp and you put like 2 pens. So stand up 2 pens. That was me putting my pens down. I don't know if you can hear that. Stand them up in front of the lamp and look at the shadows of the 2 pens. And you might notice that the shadows, depending on the angle, are different in length. Now, move the lamp further away. And keep moving the lamp further away until you're 151 million kilometers away from those pens. And then tell me, how would those 2 shadows compare? And what you would find is that the 2 shadows of those pens, if they're the same height, will be exactly the same height. And what this tells us is that no matter what, when the sun's rays hit us from 151 million kilometers away, so let's say we've got this sun ray here and this sun ray here to the tip of our shadow. So I'll lengthen the shadows to make this work. What we will find is that this angle, if we draw a line straight down, let's call this x, and this angle is also x, we will find, oh, let's make them y, because we already used x. So the angle the sun makes with each of us is identical, regardless of how tall we are. The angle that it makes with a skyscraper is theoretically the same, or very, very, very close. It's not actually the same, but it's so close it doesn't matter. because it's 150 million kilometers away. Now, of course, we have a right angle here, right? Sort of under the middle of James' feet up to his head, and his brother also makes a right angle. So we have two triangles. This angle matches, and this angle matches. Sorry, the right angles match, which means this third angle has to match. So what we have here is a similar pair of triangles. And that's what this unit is called, so this shouldn't be surprising. And what this allows us to do is, if we know these are similar triangles, we can quickly use the numbers here like we do with similar triangles. And I'm going to make it even easier. So let's do it like this. We don't need the third side, so let's ignore it. Let's do James first. So 1.5 over 2, that's James and James's shadow, equals James's brother over James's brother's shadow. Okay? So we always have to have like people on top or object on top and shadows on the bottom. And now we solve it. We flip and we flip. We multiply by 0.75 and put a dot, and we multiply by 0.75. These cancel, and we get 0.75 times 2 divided by 1.5 is 1. So brother's shadow is 1 meter long. Now you may have noticed that the brother's twice as tall, so his shadow will be twice as long. But even if you didn't notice that, the math works. It works every single time. Okay, I have 4 practice questions for you. A couple more shadow questions. I encourage you to draw a diagram first. And finally, I want you to explain how you know these triangles are similar. Go back in the video and you can see it. And then I want you to solve for the missing side. So solve for T and solve for P. I'll post the answers at 3 o'clock, and then you have yourselves a great weekend, which is like 3 or 4 days these days. Okay, folks, reach out if you need help or if you have questions. I'm always happy to help.